He's dragging a coin heavier than a piano across the treasury floor, and somehow he's still nowhere near rich. The emperor's deal sounds unbeatable. The numbers keep doubling, and yet the whole reward collapses. So what's the catch? Imagine winning a great victory, asking the emperor for a comfortable retirement, and hearing a surprisingly calm offer instead. No giant chest of money, no dramatic ceremony. You may visit the treasury once each day and take exactly one coin. At first, that sounds annoyingly small, maybe even insulting. But emperors love hidden twists, and this bargain is stranger than it first appears. Why would anyone trade a fortune for a single daily coin? Here's the twist. The first coin has ordinary brass coin value. The second is worth twice as much. The third doubles again. Then the next doubles again, and again, and again. Suddenly, that tiny daily payment starts sounding clever. A slow reward turns into a rapidly growing one, and the pattern feels almost magical. If every day doubles the last, the emperor might seem unexpectedly generous. But a rule this neat usually hides a catch somewhere. And here comes the condition that changes everything. The emperor will gladly mint whatever coin value the rule demands, so there is no shortage of money. But the general must physically carry each day's single coin out of the treasury by himself. No servants, no wagon, no team of mules. Just one man and one increasingly valuable coin. That sounds manageable for a while, but if the value keeps doubling, what happens to the coin itself? At first, this feels easy, then the growth turns ridiculous. By day 15, the coin is already around 80 kilograms. By day 17, it is roughly 328 kilograms. On day 18, he barely drags out a monster worth 655 kilograms in brass and collapses afterward. The pattern is still doubling, but his body is definitely not. So the deal sounds rich on paper, yet real life shuts it down fast. After stopping there, what has he actually earned? Now we reach the real puzzle. He stops after day 18 because the next coin is beyond him. So we are not asking what the deal might become in theory. We are asking what he actually carried away before collapsing. Add up every doubled coin from day 1 through day 18, then compare that total with the fortune he originally wanted, worth 5 million brass coins. Is he surprisingly close or nowhere near it? Let's write the actual values he collected. Because each coin is worth double the one before, the list is a geometric sequence: 1, 2, 4, 8, 16, and so on. Keep doubling all the way to day 18, and the final coin is worth 131,072 brass coin equivalents. This step matters because the puzzle is about the full haul, not just the last heavy coin. Once the sequence is visible, the total becomes much easier to find. Now add everything from day 1 through day 18. That means 1 plus 2 plus 4 plus 8, continuing through every doubling step until 131,072. When you sum the whole series, the total comes out to 262,143 brass coin equivalents. That number is the complete value he really removed from the treasury before the process stopped. So despite the huge 18th coin, the entire collection is still just a 6-digit total, not some endless mountain. There is also a fast shortcut for any doubling sequence that starts at 1. The total is always 2 times the last term minus 1. Here, the last term on day 18 is 131,072. Double that, and you get 262,144. Subtract 1, and the total is 262,143. Same answer, much faster. This little pattern is the reason powers of 2 show up so often in puzzles. The sums behave in a very tidy, satisfying way. Next, compare that real total with the reward he originally hoped for. The puzzle says his target fortune was worth 5 million brass coins, but his actual haul was only 262,143. Even before doing any fancy ratio, the gap is obvious. The requested amount towers over what he managed to carry away. So the daily doubling sounded powerful, yet the stopped at day 18 reality is much smaller than the retirement fortune he had in mind from the start. To measure the shortfall, divide the desired 5 million by the actual 262,143. The result is about 19. That means his collected total was only about 1/19 of what he originally wanted. This is the point where the bargain flips from impressive looking to disappointing in a very precise way. The doubling did create fast growth, but not for long enough. Physical limits ended the process before the numbers could catch up to the emperor's size promise. So, here's the puzzle's neat lesson. Doubling sounds explosively generous, and mathematically it really does grow fast. But in this bargain, value is tied to a physical coin that must still be carried by one person. The numbers rise, yet the body hits a limit first. That is why the offer feels enormous, while delivering far less than it seems. Exponential growth is powerful, but real-world constraints can stop it surprisingly early. This puzzle hides a brutal false assumption. Bigger numbers don't always mean a bigger payoff. If that kind of logic twist hooked you, click the video on screen for another paradox that quietly breaks your intuition.